today's video. This video is the first in the new series on Quantum Espresso, your go-to tool for powerful computational material simulations. If you ever wanted to explore the world of electronic structure calculations, band structure, or density functional theory, then you are in the right place. Now, before we dive into running simulations, there is one very important thing we need: a Linux environment. Quantum Espresso was built for Linux, and so most computational tools you will work with will run best on Linux too. By the end of today's lesson, you will have a fully functional Linux terminal running inside your Windows computer, and you will be ready to install Quantum Espresso in the next class. So grab your laptops and let's get started. First things first, what is Linux? Linux is an open source operating system software that manages all of the computer's hardware and software resources and provides services for computer programs. Linux is built around a core called the Linux kernel, and anyone can freely use, modify, and distribute it. Kernel is just a part of this operating system that controls how your programs use hardware resources. Okay, think of the kernel like the engine of a car. It's hidden under the hood, but it powers everything and manages how the car responds to the driver's action. The other part of the Linux operating system is the Linux distribution, popularly known as the Linux distro. The distro is a complete operating system built around the Linux kernel. Developers package the kernel together with extra softwares like desktop environment softwares, system libraries, package managers, and utility softwares to make the kernel more usable. Popular Linux distros are Ubuntu, Debian, Kali Linux, and Fedora. Now, why do computational physicists love Linux? Why Linux? Linux is an open source software, which means its source code are available to the public to view, modify, share, and use entirely for free. Unlike proprietary softwares like Windows, which do not even grant public access to their source codes and require payments to use most of the available features. Linux is also compatible with high-performance computing machines such as supercomputers and HPC clusters. Almost all supercomputers and HPC clusters in the world run on Linux. Talk about efficiency. Linux lets you run heavy simulations and other resource-intensive tasks with a focus on minimal resource usage. Linux also allows you to easily install scientific packages such as Quantum Espresso, which we'll be using in future videos to come. There are four methods to get a Linux operating system on your Windows. First is through WSL, which stands for Windows Subsystem for Linux. It is a solid and convenient way to install and use Linux on a Windows machine without any complex setups. Secondly, you can install Linux on a virtual machine software and launch the Linux distro like an app. Dual boot method lets you install Linux alongside your existing operating system. At startup, you can choose which operating system to boot into, Linux or Windows. Alternatively, you could also completely wipe off your existing operating system and install Linux as the only operating system on your computer. In this lesson, I'll be showing you how to install a Linux distribution using the Windows subsystem for Linux and virtual machine method. Let us get started.